Today, we marvel at the amazing thing that is known as the electron. Some facts you need to know about electrons. Each electron has a charge of -1, so 2 electrons would have a total charge of -2, 5 electrons would have a total charge of -5. Each electron has a mass of 1/1836th of an AMU. In other words, it takes 1,836 electrons to weigh the same as a proton, which is why we don't include them when we do atomic mass number. Because atoms are neutral, the number of protons is equal to the number of electrons. Notice here that we have the number of protons shown as the atomic number, and this is the electron configuration for each energy level given. So there's 2 electrons in the first energy level, 7 electrons in the second energy level, for a total of 9 electrons, as well as 9 protons. In calcium, there are 20 protons. There are 2 plus 8 plus 8 plus 2 is 20 electrons as well. The number of electrons that energy levels can hold, the first energy level can hold up to a maximum of 2 electrons. The second can hold up to a maximum of 8, the third can hold a maximum of 18, and the fourth can hold a maximum of 32. Notice that you don't necessarily have to fill one energy level before moving on to the next. This is because there's something going on deeper than just energy levels. So again, the first energy level can hold up to 2, the second can hold up to 8, the third can hold up to 18, and the fourth can hold up to 32 electrons. Much in the same way a town can be broken down into roads, energy levels, or principal energy levels, can be broken down into sublevels. And there are 4 basic sublevel types. The S sublevel, which can hold up to 2 electrons, the P sublevel, which can hold up to 6 electrons, the D sublevel, which can hold up to 10 electrons, and the F sublevel that can hold up to 14 electrons. The number of sublevels that any energy level can have is equal to the principal energy level number. For example, the first principal energy level can have 1 sublevel, the S sublevel. The second energy level can have 2 sublevels, S and P. The third energy level can have 3 sublevels, S, P, and D. And the fourth energy level can have 4 sublevels, S, P, D, and F. Notice that the sublevels repeat themselves as you go up in energy level. Also note that S always holds up to 2, P always holds up to 6, D always holds up to 10, and F always holds up to 14. You must complete one sublevel before moving to the next sublevel. If you want to expand the basic configuration given on the periodic table, what you do is you take a look at each energy level. That's the first energy level, which consists of an S sublevel. And there's 2 electrons, which means the S sublevel is filled. Then there's the second energy level. The second energy level also begins with an S sublevel, but there's only 1 electron. Now the S can hold up to 2, but it doesn't mean it has to have 2 in it. That is the expanded or sublevel configuration for lithium. For chlorine, we expand it the same way. Here's the first energy level, which is made up of an S sublevel. There are 2 electrons. 1, first energy level, S sublevel, 2, the number of electrons in that sublevel. Here's the second energy level. Always begins with an S. Now there's 8 electrons, so we know S has been filled. How many more electrons do we have to account for? Well, 2 plus 6 is 8, so the rest of them go into the 2p sublevel, 2p6. And that accounts for the 8 electrons in the second energy level. There are 7 electrons in the third energy level. 3s2, 3p, well, we only have to go up to 7. 2 plus 5 adds up to 7. So that's the expanded configuration for chlorine. Notice that every energy level will start with the S sublevel. Then we'll move on to the P sublevel. Once you've used up the electrons in that energy level, you move on to the next one. So this would be 1s2, 2s2, 2p6, that takes care of the 8 electrons. This also has 8 electrons, so we're going to mirror that. 3s2, 3p6, and that takes care of those 8. These 2 electrons go in the fourth energy level, 4s2. And that's how you expand a basic energy level configuration to take into account the sublevels that an energy level is made of. In the same way that a road can be broken down into individual houses and properties, Sublevels can be broken down into orbitals. Now, the longer the street, the more houses can fit on it. The shorter the street, the fewer houses can fit on it. Same thing goes for sublevels with orbitals. The bigger the sublevel, the more orbitals can fit in it. The smaller the sublevel, the fewer orbitals can fit in it. An orbital is a region of space where you're likely to find up to 2 electrons. These electrons will have opposite spins. Since an orbital can hold up to 2 electrons, since S has 2 electrons, that's 1 orbital. Since P can hold up to 6 electrons, 2, 4, 6, that's 3 orbitals. We represent orbitals as boxes. Because the D sublevel can hold up to 10 electrons, that would be 2, 4, 6, 8, 10, 5 orbitals. And because the F sublevel can hold up to 14 electrons, 2, 4, 6, 8, 10, 12, 14, that's 7 orbitals. We represent the spin of the electrons as arrows. We have up spin and we have down spin. And when you put the arrows in, the up arrows will go in first, followed by the down arrows. Let's do the configuration for this. First, we need to get the expanded configuration. 1s2, 2s2. Now we draw the boxes. We'll label each box with the sublevel. This is the 1s sublevel, the 2 electrons. One has up spin, the other has down spin. Second energy level, S sublevel. S sublevel has 1 orbital. 1 electron has up spin, the other electron has down spin. Sulfur is 2-8-6. That's 1s2, that takes care of those 2. 2s2, 2p6, that takes care of those 8. 3s2, 3p4, that takes care of the 6 in the third energy level. 1s, up, down. 2s, up, down. 2p, now p has 3 boxes. 3 boxes for the 6 electrons, 2 electrons per orbital. Now let's imagine, if you will, that you've just moved into a house and there are 3 bedrooms for you and your siblings to choose to sleep in. Now if there's only one of you, you're just going to choose a bedroom. If there's 2 of you, you're not going to share a bedroom, you're going to want your own bedroom. Well, electrons repel each other, so the same thing happens. They're going to choose a different room to sleep in or a different orbital to occupy. What if there's 3 of you? Well, if there's 3 rooms, that's great. Everybody gets their own room. What if there's 4? Well, someone's going to have to share. The first 3 get their own room. The 4th is going to have to bunk with the first. And so on, and so on. The up arrows go in first, followed by the down arrows. 3s, up, down for these 2. 3p, now we have 4 electrons vying for 3 spaces. The first 3 go in alone, then the 4th one has to bunk with the first one. Let's do Krypton. We have 2, that's 1s2, 8, 2s2, 2p6, 18, 3s2, 3p6, 3d10, 8, 4s2, 4p6. And that accounts for all the electrons. 2, 8, 18, 8. S is always made of 1 box. S is always made of 1 box. P is always 3 boxes. 6 electrons. 1, 2, 3, 4, 5, 6. 3s. Up, down. 3p. Up, 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 down, down, down. Now let's do 3D down over here. 3D. Now D is 5 boxes to fit the 10 electrons at 2 per box. Up, 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 up. Down, 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 down. Almost done. 4s. Up, down, and then there's 4p, 6 electrons, which means the first 3 get their own, and then the other 3 have to share. And that is the orbital notation or box diagram for Krypton. And that's how to diagram electrons from their most general energy levels to the most specific orbitals.